Introduction to Factoring. The learning objectives are find the greatest common factor of monomials, factor polynomials when the terms have a common factor, factoring out the greatest common factor, and factor certain expressions with four terms using factoring by grouping. As you can see, the word factor is being used several times in the learning objectives, and that is going to be the focus in this chapter. So to get us started in this lesson, let's look at our key terms. Number one, to factor a polynomial is to express it as a product. A factor of a polynomial p is a polynomial that can be used to express p as a product. A factorization of a polynomial is an expression that names the polynomial as a product. And the last one, certain polynomials with four terms can be factored using factoring by grouping. Now let's look at some sample problems. The first one I want to look at, we have three monomials, negative 11x to the fourth y to the third, 33x cubed y to the fifth, and 55x squared y. We are going to just identify what the greatest common factor is among these three monomials. The easiest way is to look at the numbers first. And the number part, or the constant part, or the coefficient of each monomial, we have 11, we have 33, and we have 55. And ask yourself, what do 11, 33, and 55 all have in common? And the answer to that is 11. 11 can be divided evenly into all of them, so that is a common factor. Remember, a factor is something being multiplied to get another number or to get the product. A factor times a factor equals a product. And 11 would be a factor of all three of our monomials. Now let's look at our x's among the three monomials. We have x to the fourth, x to the third, and x squared. If we were to expand all of these, the first one we would have to write 4 x's. The second one we would be writing out 3 x's. And the last one we'd have 2 x's. So how many x's do they all have in common? Well, they all have at least 2 x's. So the way we would write that is x squared. Now let's look at the y's. We have y cubed, y5, and y. The first monomial has y cubed, or y times y times y. The middle one has y to the fifth, which would, if we expanded that, would be 5 y's. And the last one has a single y. So they all have at least one y, or y to the first. So our greatest common factor is 11x squared y. Now let's use this idea of greatest common factor to actually factor binomials. So I have 3 samples here. So let's look at the first one, x squared minus 10x. So you're going to look at each term. We have 2 terms. We have x squared and we have a minus 10x. What do those 2 terms have in common? Well, these 2 terms happen to have an x in common. So we are going to factor out an x. And then what is left over after we factor an x out? Well, x squared divided by x is x, and negative 10x divided by x is just a negative 10. We can always check our work when we are factoring out a greatest common factor by multiplying our factor back through and making sure that we get what we started with. X times x is x squared, and x times a minus 10 is a minus 10x. So we know that we are correct because when I distribute back through, I get what I started with, and my 2 terms inside the parentheses do not have anything in common. So now let's try the second example, 3x to the 6th plus 12x to the 4th. Well, this one has some numbers involved. So let's look at the numbers first. We have 3 and 12. What factor do those have in common? And that would be a 3. 3 divides evenly into both 3 and 12. Now we have x to the 6th and x to the 4th. What do they have in common? Well, they have x to the 4th in common. So now, let's see what we would get when we factor that out. 3x to the 6th divided by 3x to the 4th would be x squared. And if we factor 3x to the 4th out of 12x to the 4th, we would be left with simply 4. Again, you can check your work. You can do it mentally, or you can write it out. Just remember that you want to multiply it back through and make sure you get what you started with. 3x to the 4th times x squared would be 3x to the 6th, and 3x to the 4th times 4 would be 12x to the 4th. Let's do one more example. 10x to the 5th minus 5x squared. 10 and 5 both have the 5 in common. X to the 5th, x to the 2nd, they've got x to the 2nd in common. Let's factor that out now and see what goes in our parentheses. So if we factor 5x squared out of our first term, we're going to be left with 2x cubed. And if we factor 5x squared out of our last term, a lot of people are tempted to say, oh, well, that's it, we can just leave it blank. That would be wrong, because a number or a monomial divided by itself is the number 1. Again, you would have noticed that if when you check, you would not have got what you started with had you not put that 1 in there. 5x squared times 2x cubed is 10x to the 5th, and 5x squared times the minus 1 is a minus 5x squared. Now let's take this idea a little bit further. In this particular problem, we have multiple sets of parentheses, and we actually have factors. We have 2 terms, and you may not see the 2 terms, but here they are. What do these 2 terms have in common? Well, they seem to have the x plus 1 in common, so just like we did in the previous problems, we're going to factor out the x plus 1. So I'm going to factor that out. That's going to come out here in front. And then what's going to be left over? Well, if I factor x plus 1 out of the first term, I'm left with x cubed. And if I factor x plus 1 out of my second term, I'm left with plus 3. As you can see now, I have a binomial times a binomial. If I want to check my work, I would use FOIL to check my work. Let's look at the second example. Again, we have multiple terms, and we see some parentheses there. Here's one term, here's the other. So now, what do those 2 terms have in common? They have 4p minus 5 in common. What's left over after we factor the 4p minus 5 out of the first term? Well, I'm left with 7p squared. And what am I left with after I factor 4p minus 5 out of the second term? Again, it looks like we would have nothing, but we really do. We would have a minus 1 because it's subtracting that entire quantity. And now this would be our final answer. Now we're going to take this one step farther. In this particular problem, we have 4 terms. We have x cubed, we have a positive 3x squared, we have a negative 7x, and we have a negative 21. So what we're going to do next is we're actually going to use something called factor by grouping, because among our 4 terms, we do not have a common factor. But if I group my terms, so I'm going to group my first 2 terms together. And I'm going to group my second terms together. So in my first group, x cubed plus 3x squared minus 7x minus 12. what do my first two terms have in common? Well, we have x cubed plus 3x squared. So they both have an x squared in common. And what's left over if I factor an x squared out of my first two terms? Well, if I factor x squared out of x cubed, I'm left with x. And if I factor it out of that second term, I'm left with a 3. Now let's go to the back half of our polynomial, minus 7x minus 12. Well, what do those have in common? Well, they have a minus 7. They're both minus, so I'm pulling the minus out with the constant of 7. And what's left over? Well, I would have an x, and then negative 7 factored out of negative 21 would be a positive 3. Now I just went from I just went from 4 terms to 2 terms. Here's my first term and my second term. Now, among these two terms, what do they have in common? Well, they happen to have an x plus 3 in common. What's left over after I factor out the x plus 3 out of both terms? Well, if I factored out of the first term, I'm left with x squared. And if I factored out of the second term, I'm left with a minus 7. Now that is our final answer. We actually had to use greatest common factor multiple times. I had to first group my 4 factors into 2 groups, factor each group, and then finally factor my remaining 2 terms.